Good afternoon. My name is T. Ravi Babu, Assistant Professor in Institute of Aeronautical Engineering College. Today, we are going to see Module 3. In that one, that is state space analysis. In state space analysis, we are going to see the controllability and observability. When we are going to taking the controllability observability test, first of all, we have to define the stability condition. Stability condition, that is, the stable is nothing but for any system. If you are having the bounded inputs, if you get bounded outputs, then the system is said to be stable. Otherwise, the system will follow the output by applying the standard test signals improperly. In that case, the system is said to be stable condition. That is, output is follows the input. Input parameters are, that is, input is follow the output, then only the system is going to be said as stable condition. For stability conditions, now I am going to taking the two conditions. That is, generally the state space representation is given for the conclusion of the controllability and observability properties for any linear time variant systems. That is, the state variable model is having the x of k plus 1 equal to f of x of k plus g into u of k. This is called as the equation, state space equation, and the output equation is y of k equal to c into x of k plus d into u of k. That is, the equation, state equation is going to be represent the dynamic of the system. What is meant by dynamic of the system is nothing but it will be having the dynamic variables, that is state variables. State variables. So what I am saying is, if you are applying the input variables, if you are getting the output, no, but in case of the control system block, we are having the state variables. That is, in control block and system block, you are having the some of the parameters. That parameters are going to be changing with the state variables. Where in equation 1 and equation 2, F, G, C or D are the vectors, matrices, vector matrices. That is, F is nothing and Fe and G is the column matrix and C is the row matrix and D is the scalar matrix. Having the size of F is having the size is n by n size, and G is the having the size of n by 1, and C is the having the size of 1 by n, and it is the scalar matrix, that is 1 by 1. 1 by 1. Now, the state variable x is also here one of the vector combination, that is state vector, and the size is nothing but n by 1. N by 1. In state equation, output equation, y and u are the output and input variables. Output and input variables. So, generally, in case of the state space analysis, the state equation and output equation are the single input and single output systems. That is nothing but SISO systems. SISO systems. The two above equations are also called as the state space model or state variable model or state variable representation. In that one, F is the state matrix or system matrix. It will contain all the elements of the states for the given system. Where G is the input matrix, it will contain the elements of the input. C is the output matrix and also it will contain the elements of the output. Where D is the state transmission matrix, it contains the system elements which is responsible for the transmission of the state. Transmission of the state. So these are the variables containing the state space equation and output equation. Output equation. Now I am going to for the controllability test. That is, For state equation, for output equation, I am going to taking the controllability of this test. So these are two equations of the linear systems. Linear systems. That is, if you define the controllability, that is, it will exist only for the an input, where the input is containing from 0 to n minus 1 for a finite number of integers. That is, in case of the controllability, transfer the initial state to x naught value. So it is said to be controllable. That is nothing but all initial state in all initial states, the controllable of the system is said to be completely controllable or simply controllable. That is nothing but in a state-based equation, the F matrix and G matrix is there now. So U of k equal to F of x of k plus G into U of k. G into U of k. State equation. In state equation, the variables are state variables. X of k plus 1. X of k plus 1 is the state variable equation. That is, if you take the any block for simple block diagram, here representation, here I am going to be representing the single block diagram. That is U1 of t, U1 of t up to so on U1 of t. Okay, these are the variables we are applying here. System, control system. That is, in that one we are having the state variables. That is x1 of t, x2 of t, x1 of t. Here we are getting the output y1 of t, y2 of t, yn of t. Like this. This is the state-based representation of the system. Here the state variables are going to be making the insert between the output and input. Output and input. That's why we are using this one. Coming for this one, controllability. So if you all the variables are going to be inserted with the input variables, then only that is the x of k plus 1 equal to f into x of t plus u into g into u of t. So that's why whether the input variables are going to be a controllable action. Otherwise, it is going to be uncontrollable. Uncontrollable. That is, controllability action is existing for initial conditions. That is, x of 0 equal to x naught. X of 0 equal to x naught. The necessary and sufficient condition for the controllability is the controllability matrix as u equal to g f g f square g f of n minus 1 into g, f of n minus 1 into g. So this is the equation for controllability test. U equal to g into f g f square g up to so on f of n minus 1 into g. Now we go for the observability. Observability nothing but here going to applying for the output section also. Output section also. That is, for the linear system, that is the linear system equations as steady phase equation and output equation. Okay, if you know the knowledge of this one, we have to apply for the input and we getting the output for finite positive integers. That is, the state is going to be analyzed at the initial state x naught and it is going to be observable for the section of the output section. Output section. That is, in that one, all the initial conditions are going to be observing. Otherwise, it is going to be unobservable. Unobservable. Okay. Now, the sufficient conditions for the observability is, it is a column matrix C into F, C, CF, CF square, C into F whole power of n. Reason here, in case of observability, C matrix is coming. C, CF, CF square and it is a column matrix. In controllability, it is coming as G, FG, F square G. It is a row matrix. Okay, it is a column matrix. Okay, in controllability G is coming, in controllability F is coming. I am going to here one of the problem. That is, for a given system, we have to going to follow the controllability or observability of the system. So these are the state space equation and output equation. Compare this one to given problem. When you are to comparing this one, we are getting is f equal to minus 1, 0, 0, 1, 0, 1. Okay, and g equal to 0, 1, and c equal to 1, 1, and d equal to 0. These are the values for comparing the state space equation and output equation with standard formation for a given problem. For a given problem. Next, coming for your first, when you are going to starting the problem, first of all, identify the order. Order is nothing but n. N nothing but the what is the size of the f value. Here f size is 2 by 2. F matrix size is 2 by 2. So 2 by 2. So the order of this matrix, this one is 2 by 2. So 2. The order is 2. And coming for the controllability test. Controllability test. So whenever this is order is 2, so because of that one, the controllability condition u is, what is the u value here? Just now you know g, f g, f square g up to so on f power of n minus 1 into g, f power of n minus 1 into g. Here n value is 2 now, substitute here f power of 2 minus 1 into g. That is, we are getting f to fg. That is nothing but up to here we take. Up to here we take. So u equal to g into fg. We got it. Okay. U equal to g fg. The controllability test in this problem, we are going to up to 2 terms only. Why? Because in given matrix, f value is 2 by 2 size. Because of that one, the 2 by 2 size, the n value is coming for 2. Order of the system is going to be 2. So in the u value, already g is given 0, 1. You have to find the f into g. F into g. So what is the f value? 0, 1, 0, minus 1 into g 0, 1. So the f size is will be 2 by 2. And what is the size of this one? 2 rows, 1 column. So what is the result of this one? We have to get the result of this one is 2 by 1. 2 by 1. Okay. So 2 rows, 1 column. Coming for here, multiplication. Minus 1 into 0 plus this one. That is nothing but 0 plus 1. 0 plus 1. Next, 0 into 0 into plus minus 1 into 1. That is minus 1. We got the 1, 1. 1 minus 1 is the fg value. Fg value. Now, substitute this one into standard form. What is that one? U equal to g is nothing but 0, 1. What is the f into g value? 1 minus 1. Okay, 1 minus 1. Next, coming for here, what we have to do first of all in case of the controllability test. Okay, so when by seeing the n equal to value, that is order of the system is 2. So first find the rank of the system, that is determinant of u. Determinant of u, that is 0 into minus 1 plus 1 into 1. What happened? This one value is coming to as 1. That is, the determinant is not getting to 0. So what happened? The rank of this one is u rank is 2. Okay. Whether it is matching with order 2, yes, n is also 2. So system is controllable. System is controllable. This is the procedure for you have to find. This is the procedure for you have to find. Okay. First of all, from the given matrix, from the given system, you have to compare with the standard formation. From comparing the standard formation, you write down the f, g, c and d values. After that one, taking the order of the system, order of the state space equation. That is, the order will be f matrix size. F matrix size. Okay, that is the value of 2 by 2. 2 by 2. So the order of the system is 2. Order of the system is 2. Okay. Now I am going to for the controllability test. When I am going to controllability test, first of all, you have to write down the order, that is n equal to 2. So n equal to 2. After that one, you are in the standard equation, that is for controllability, u equal to g f g, okay, f g f square g up to so on f power of n minus 1 into g. Here n equal to 2. N equal to 2. So f power minus 1 into g, that is fg. So only fg is up to fg you have to write down. That is nothing but 2 variables up to. That's why I written this one. That's why I written this one. Here g is there already. So only you have to find the f into g. So find the f into g. This is coming. Okay. Substitute this g value, fg value. Fg value is here. And the g value. In the question they given now g value. This is the g value. For substituting this one, we get the u value like this. U value like this. After that one, find the what is the condition for controllability procedure for finding. If the system is finding if the given system is controllability, how can you check? First, whatever condition you have to find, that condition value we have to make it magnitude. Find the magnitude. You have the u value now. That u value magnitude is, it is 2 by 2 matrix AD minus BC. The magnitude y is not getting 0. That's why for this 2 by 2 matrix, you are not getting 0. That's why the rank of the matrix is 2. U matrix is 2. And what about the n value? Order also will be 2. So it is matching. So the system is controllable. The system is controllable. Okay. This is a procedure. Same process we can do for any type of the systems. That is 3, 4, 5 mat size of the system. Coming for the observability test. Observability. What is the observability formula? V equal to column matrix C, CF square up to so on CFN minus 1. C. This CFN minus 1. Okay. In the problem, C we given, F is given. What is the order? Order is 2. So C into F power of 2 minus 1. That is C into F. Up to CF you have to write down. That is nothing but we getting as column matrix C, CF. Now we have to find the CF value. That is nothing but first we have to find the CF value. Okay. So what is the C value here? CF value we have to find. What is the C value here? 1, 1. 1, 1 into F value minus 1, 1, 0, minus 1. The size of the FC value is 1 by 2. It is 2 by 2. When you have to go into multiplication factor, this is cancelled to 2. So the size will be 1 by 2. That is nothing but 1 row, 1 column. Okay. 1 row, 2 columns. Okay. 1 row, 2 columns, nothing but like this. First one. 1 into minus 1 plus 1 into 0. So we got the first one is 1. 1 into, I can write 1 into minus 1 plus 0 into 1 into 0. Otherwise 0 to 1. 1 into 0 order wise. Completed. Next one component. 1 into 1 plus 1 into minus 1. Okay. 1 into minus 1. What we have to get here? Here 0. It is minus 1. It is 0. Okay. We got it. Minus 1 into 0. CF value. CF value we got it minus 1 into 0. So what happened? V equal to, this is the formula now. V equal to, see, what is the C value? 1, 1. 1, 1. Okay. Next, CF value minus 1, 0. Minus 1, 0. Okay. Here n equal to, remember. Next, coming for the rank. For finding the rank, first you have to find the magnitude of this one. That is AD minus BC. 1 into 0 minus 1 into minus 1. That equal to 0 plus 1. That equal to 1. Magnitude is getting here 1. Okay. So what happened? It is not getting to 0. If you getting the 0, nothing but go for the next below order of the matrix. We have the order matrix. So here we are not getting the 0, no. So that is, it is not getting to 0. Not getting to 0. So the rank will be 2. What about the order? Order also will be n equal to 2. So rank equal to order, no? Rank equal to order. So the system is completely observable. Completely observable. Okay. This is the way we have to find the observability and controllability of the system. Controllability of the system. Okay. Okay. This is a topic for finding the observability and controllability of the system. Now, if you are interested, you see the more problems on Ogata QO book or M Gopal book on the content of the digital control system. Okay, thanking you.
Like, share and subscribe. Hit the bell icon for more updates.